All right. 3.2. Polynomial equations in two variables. All right, anytime we jump to two variables, that typically means we have an x and we have a y. And that's what we're going to see. All right. We're really going to focus on graphing the solutions. And that'll take us to an xy coordinate grid. And really what I want you to see today is this lesson is largely about graphing functions, typically lines and quadratics, which is a review of some stuff that we've covered. And then there's just this added element of shading. And that's really at the end of the day what it's about, is graphing and knowing where to shade the set of solutions. All right, here's our shading rules. Okay, very important. If we have a greater than or equal to, shade above the line. If it's less than or equal to, shade below. Yeah, that's fairly intuitive. If you were to guess, I think that's the way you would guess. If it's greater than, shade above; less than, shade below. And it's worth reminding here that these signs right here, because oftentimes I think we take this for granted and don't emphasize enough what these are. Okay, those ones that open up to the left, that's a greater than symbol. These ones that open up to the right, that's a less than symbol. Okay. If it's just strictly less than or greater than, use a dotted line. And that's saying that the points that actually fall on the graph of that particular line, those are not solutions. Okay. If it's greater than or less than or equal to, like those, we're saying the points that actually form the line, we want to include those, and we'll mark that with a solid line. So here we go. Let's sketch y is greater than x plus 3. Okay. Now, so we've got this greater than sign, and here's what it really means. Eventually, after we graph a line, we're going to shade above it. Okay. But here we have a line with a slope of 1, and it's got a y-intercept of 3. It's a line. Okay, let's graph it like we would any other line. And then when we're done, we'll just note a shade above. Okay, so let's blow this up and take a look. All right, so we'd use our typical reference points. It's got a y-intercept of 3, and its slope is 1. So notice I'm just kind of going up 1 over 1, and using its slope to graph some other points. Okay, notice they're all just falling in a nice straight line here. All right. Now it was greater than or equal to, so I want to include all these points. So I'm going to connect those. And there I've graphed the line y equals x plus 3. Okay. Now it's greater than, so I am going to shade above that line. Okay. I'm not going to shade it all that thoroughly. I'm just kind of using some lines here to represent that this is the shaded side. And all of the points on that side of the line, those are solutions. Okay? And again, I shaded above because going back to the original inequality, it was a greater than sign. Okay? So again, what I really want you to notice here is graph the equation. And you can treat it like an equation, even though it's an inequality. If you want to, as you're making the line, pretend this is y equals x plus 3. And graph that just like any other linear function we've graphed this year. And then, once you've got the graph, just pay attention to which side should be shaded. All right, here's one where, same idea. Same idea. We just have a little solving we got to do first. The other one was already solved for y. And we'd like this one to be in that form as well. And let's subtract 2x from each side. I get negative 4y is greater than 6 minus 2x. And I divide both sides by negative 4. Divided by a negative, so the inequality will switch. Y is less than negative 6 over 4 plus 2 over 4x. Okay? I have a line. It has a slope of 1/2. It has a y-intercept of -1.5. I'm going to graph these. I'm going to graph this line using those pieces of information. And right here, this less than sign, again, that tells me after I've graphed my line, shade below. Shade below that line. So let's blow up our graph here and take a look. Okay. Oh, a -1.5 is about right there. Notice I'm going up 1 over 2, and if I continue to plot these points correctly, they'll form a line, obviously. If I do something incorrectly, they won't. One of the points will kind of stand out. Now this is a strictly less than, so these points that are on this line, they are not solutions. And that's why I'm going through here, and I'm marking this line with a dashed line that says, yes, this line forms the boundary of the to points that are solutions and ones that aren't, but the points on this line are not solutions. Okay? The solutions are below. Okay? All of these points down here, those are solutions. Okay? So that is the side that I would shade. Okay? All those points down there. Okay? And again, notice the dashed line that says the points that are on the line, -6/4 plus 2/2. Excuse me, 2/4. Probably should put this in simplified terms here. -3/2 plus 1/2. Okay, the points on that line are not solutions. How about a quadratic? Okay, and I mean it seems like it'd be kind of hard to do, but again, this is really about producing a graph. Okay, that's all it is. So I want to find some key points on this quadratic so I can produce its graph. I'm going to start by finding some x-intercepts. This quadratic's factorable. You can split it up into two factors of x minus 2 and x minus 3. Okay. 2 and 3 are the x-intercepts. Now halfway in between those, if I wanted to find the vertex, which would be another good reference point to have, halfway in between those would be 2.5, but to get my y-coordinate, I would have to evaluate that. 2.5 squared minus 5 times 2.5 plus 6, and I get -0.25. Okay? Not to mention the fact that right here, my y-intercept is 6. Okay? So there's another reference point as well. Let's put all this together and just see if we can come up with kind of the basic structure of the sketch of this quadratic. We got an x-intercept right here, y-intercept right there. Okay, that's about where the vertex was. 1, 2, 3, 4, 5, 6 points up. That's where I found my y-intercept. And I should, okay, this is 2.5 right here. I should go over to 5. Okay, I can use a reflection point because it's this x-intercept is 2.5 units from the axis of symmetry, so I can go another 2.5 past. Okay, and get a point to graph right there. And there's a really rough sketch of my graph going through the y-intercept, the reflection point, okay, and my vertex. Now let's zoom back out here for a second. Okay, it's less than, which again means shade below. The note said shade below the line. Obviously, this graph isn't a line. All right. But we've got two possible areas to shade, kind of on the bottom, on the outside of the parabola, which would be all these points. And notice those are the ones I'm shading, because those are my solutions. Okay? And all the points on the inside, okay, those would be considered above. Those I'm not shading. Okay. So again, this is coming from the fact that y less than or equal to that quadratic that's why I'm shading below. Okay. So there's a quadratic. Same idea. The focal point is really produce the graph first, and then just the only extra piece is which side do you shade. Let's take a peek at one with a single variable. Okay, kind of an interesting little one here. On a two-dimensional grid, I can do a single variable. Okay, I want all the points that have a y-coordinate between -3 and 4. Okay, between -3 and 4. Okay. Well, y equals -3 is down here. Y equals 4 is up here. Okay, and as I zoom back out, all right, I want the y values that are in between those two. Any point that has a y value bigger than -3, less than 4, well, that is going to be all of these points right in here. Okay, and that shaded area would continue on forever in either direction, because when I go left to right, that involves the x-coordinate. Okay, and the x-coordinate has nothing to do with this, because this is actually a single variable. Okay, it just involves the y value. And all those points that fall in the shaded area, they would all have a y-coordinate that's greater than or equal to -3, but less than or equal to 4. Okay, and therefore, no matter what the x-coordinate would be, they would be solutions. Here's another one that's a single variable. Okay, here I just have an x. I think this one has an absolute value sign. And just a review of these, okay, one thing I can do is drop the absolute value sign and solve that. Okay, because it's a greater than. Or the other option I'd have is x plus 2 less than -2. Okay, so I want anything that's less than -2, greater than 2. Subtracting 2 from both sides, I get x less than -4. That's something I want to graph and shade. And x greater than 0. All right, so those two areas. Now remember how the y values involve horizontal lines? These will involve vertical because I'm just dealing with the x variable. I'm paying no attention to y. I'm not concerned what the y variable is. I would put a dashed line right here because that's x equals 0. Okay, and then over here at 1, 2, 3, -4, there's x equals -4. Dashed line because these were strictly less than and greater than signs. All right, I wanted all the points out here, okay, because again, this region is formed by the inequality x less than -4. I want all the x values, or all the coordinate points that have an x value less than -4. Just like over here, I want all the points that have an x value that's greater than 0. Okay, so I will shade all of the points out there. Okay, so there's one that has an absolute value. Those cases really covered just about everything you could see for this particular learning target. All right, we'll spend a second day on it, so if you have questions, let's talk about those more, but that's all for 3.3 day 1.